Hello, how are you?
Hello. Hey, Professor.
How are you
Yeah.
guys doing? I know that you guys, the semester is almost over. You guys, I'm sure you're excited. Um, let's start by let me start by showing you what we have this week. Go to your classroom. It's your classroom right here. It's a classroom. Now we have week 14 announcements. So we are still on chapter 9. Hopefully we'll finish it by next week. It's on test of hypothesis. And the assignment due is just homework 9 and test 2. You can complete them on Sunday, which is the 24th. I will try and put a collection of videos you can watch uh, while taking you can watch, some questions I solved in those topics. Like you can, links to those videos that you can watch. That can help you in that test. Yeah, of course. Okay. Then semester project, please continue working on it since it's due on December 1. Anytime you finish, you can submit it. So let us begin. So with these some examples on test of hypothesis, the traditional method we did for the mean, hypothesis testing for the mean specifically. Now let us do the p-value methods of testing hypothesis. Okay, that's what we'll be doing tonight. At least that's where we'll start. Now, don't forget that the p-value method actually simply means the probability. P-value means the probability value. So we can use that value method to test hypothesis. And this process is still the same, except that this time around, we are not using the critical value. We are using the p-value. So we state the hypothesis and identify our claims. We compute the test value. Then instead of finding the critical value, we'll find the p-value. Then we make a decision. Then summarize our results. Now, in the test of hypothesis, the traditional method, we reject null hypothesis if the calculated value, which is our answer, is bigger than the critical value or is equal to the critical value. If it's less than the critical value, we don't reject HO. Now, in the p-value method, is the opposite we are doing. If the p-value is less than or equal to alpha, we reject null hypothesis. Now, if the p-value is greater than alpha, we do not reject null hypothesis. Okay? And that's how it goes. Let's try maybe two examples of this. One will be 1 tera and the other one with 2 tera. Look at this one. It says a researcher wishes to test the claim that lifeguards in Ocean City, that the average age of lifeguards in Ocean City is greater than 24 years. She selects a sample of 36 lifeguards and find that the mean of the sample is 24.7 years with a standard deviation of 2 years. Is there evidence to support the claim at alpha 0.05? Use the p-value method. Now, again, we'll start by stating our hypothesis HO and H1. Okay. Now, let's look at the keywords here. The first one is the average age. Then you say is greater than 24 years. That's the two keywords. So now, is greater than means to use the greater than symbol. Okay. and you can only use that symbol in the alternative hypothesis. So the average means mean. So we're gonna put mean is greater than 24 years. That is the claim of this that there is this research want to test. Then of course, like I explained to you in last time, the null hypothesis and alternative hypothesis, they say things that are opposite of each other, which means that H will now become mean less than or equal to mean less than 24 years. But since you cannot use the less than symbol in the null hypothesis, you can only say mean, okay, less than or equal to 24 years. Okay. Now, it said test the claim at alpha 0.05. Okay. Alpha 0.05. That means your chance of committing type 1 error is 5%. And your chance of not committing type 1 error is 95%. So now, because this is, look at this, this operator is pointing on the right side. So this is the right third test. A right third test. So now we're not gonna use it, we're not using a critical region this time around. We're using the p-value method. So we have it in this form. Let's get to some other statistics that they give us. They say that the average age of lifeguard in Ocean City is 24 years. So mu, okay. Oh, excuse me, sorry, let me say. Mu equals 24 years. To test this claim, this researcher, give me 1 minute. Let me check something here. Just 1 minute, 1 minute, 1 minute, 1 minute. Okay, just one. Okay. Anyway, in 4 years. Now, to test this claim, she select a sample of 36 lifeguards. So N is 36. And for that 36 lifeguards, she found that the mean is 24.4. You have sample mean X bar. So I'm gonna make it X bar. So I'll make it, I figured out a way to make it X bar. X with bar on top of it. S bar equals 24.7 years. Now, the standard deviation of the population is 2 years. So I'm going to put standard deviation here, which is going to be delta equal 2 years. With this, we can now run the test. I remember the formula again. Let me show you. Okay, I'm going to show you when we go to that workbook. I'm not using. Let me write this thing down, and we can run the test. Yeah. Formula have mean mu equals 24 years. Sample size is 36. X bar is 24.7. Delta is 2. So we go to the other, since we cannot put the formula here, it won't allow us to put the formula here. So let's go to this workbook and put it from there on the test. We have Z equals, okay, I'm making this, let me make this 18. Make it 18 so you can see it properly. Z equals X bar, which is X bar, excuse me, minus the mean. Okay, which is, this is the mean, divided by the standard deviation of delta over the square root of n n. Okay. Which means equals. Now let me show you the summary statistics again. You can see mean is sample population mean is 24. A sample of 36 we are selected. If you can see this is selected as a sample of 36 lifeguards. Sample mean X bar is 24.7. Population standard deviation is 2. So let's go and put them in the formula. We have it right here. Okay. So 24.7 minus 24 divided by standard deviation of 2. Excuse me. And put the 2 over the square root of 36. Okay. This gives us equals, let me write this down and we can get it from here. Z equals 24.7 minus 24 divided by the standard deviation of 2 over square root of 36. Okay. 36. Yeah. So we have excuse me. This value, let me write it down, put the equal sign. We can look at our calculator. Let me see if I can find it. Calculator. Let me see. Can share this. Our calculator right here. So I'm going to share it from here. So we got for our calculator, we have equals, we have 24.7 minus 24 divided by standard deviation of 2 over square root of 36. Which is 2.1. 2.1. That is 2.10. That's what it means. 2.10. Okay. 2.10. So we're going to copy this and paste it right there. Okay. Into our main workbook. So I run the test. This is the result. Okay. Now we can now calculate the p-value. Remember, this is like this form, and the mean is 24. Okay, let's say 24 with the center line, or just 0. I'll just put 0 if you like. I usually use standards. Yeah, so 0. Oh, excuse me, sorry. I think I messed up with something here. Okay, 0. So from here I can draw it. Okay. I can put a line, you know how it is. And then this adjustment. Then I can put a curve, normal curve from here. If you still remember this. So we have a center line. And this should be because it's greater than 24, I mean, it should be in the right there. Greater than, so you're gonna be right there. And if you remember when we are doing normal distribution, I mentioned that whenever it's at the tail, you subtract from 0.5. So it's right there. Okay. Now, this is how it looks in the right there, right? Or student alpha is 0.0. So now, let us now find the p-value. Now, since that we have this, okay? So the p-value is, find the p-value. To find the p-value, we use p-value, make sure you're seeing this. So the p-value now becomes value becomes, now is, we look for 2.10 in the table of normal distribution. Okay? 2.10. And then we substitute this on the right tail. We look for this on the table of normal distribution. Then we remember it's because it is at the tail, whether it's on the left tail or right tail. Remember that half of this is 0.5 and this half is 0.5. So we're looking for only this part. You subtract this, whatever you found on the table, from 0.5 to get it. So 0.5, okay, minus 2.10. Let's find it on the table. 2.1 under 0. See, you can see the table area under the standard normal distribution table. Remember this table, I say use this one so that you don't get confused. This one is the one we're using for the class. The one in the homework, which is cumulative. If you know how to use that, fine. But if you're using this one, this rule that I'm showing you is what applies, okay? So 2.1, look at 2.1 here. So it's 2.1. This is 0. So you see 2.1 under 0, you can see right here. 0.4821. So you're going to be 0.4821. Okay. Okay. 0.4821. I want to make this thing unbold it and make it 18. So that will give us the p-value. So the p-value is to find the get this on the table and find this from subtract from 0.5. So let me write this down. P-value 0.5 minus 0.4821. Okay. So you have on the calculator we have 0.5, 0.500 minus 0.4821. 0.017, 0.0179. So I'm going to go there and put it right here. Okay. 0.0179. Now, we have stated our hypothesis and identified our claim. We have our alpha, which is this 0.05 is the alpha that what was given to us. Okay, 0.05. So now we have, we run the test, we got 2.1, and we find the p-value. It is now to make decision. Okay, decision. Okay, p-value is 0.05. Then, sorry, alpha is 0.05. Then our p-value equals 0.0179. Now, let's see how this decision. Remember, I explained how to make decision in this case. Make decision, it says here, if the p-value is less than or equal to alpha, reject null hypothesis. If the p-value is greater than alpha, do not reject null hypothesis. In this case, you can say that this is alpha, this is p-value. P-value is less than alpha. In that case, reject HO because the p-value of 0.0179 is less than the alpha of 0.05. See? Because it's less than the alpha of 0.05. We reject the null hypothesis. Okay? So that's why you reject. So now our conclusion now becomes conclusion. When you look at so we rejected this one. I mean, this one is correct. So, which means that there is, I said, is there evidence to support the claim at alpha 0.05? So he said that there's enough evidence to support this claim that the average age of lifeguards in Ocean City is greater than 24 years. So we rejected my hypothesis. That means this claim is correct, that they are greater than 24 years. So there is enough evidence to support the claim that the average age of lifeguards in Ocean City is less than, is greater than 24 years. That's our conclusion. So, any question on this, guys? Any question? So, no question. Good. Excellent. Excellent. Now, let us do another example of this. When it is 2/3, like this one says here. Says, let me make sure I've already seen this. It said that a researcher, this one. A researcher claimed that the average wind speed in a city is 8 miles per hour. A sample of 32 days has an average speed of 8.2 miles per hour. The standard deviation of the population is 0.6 miles per hour. At alpha 0.05, is there enough evidence to reject the claim? Use the p-value method. Okay. So again, we state the hypothesis, identify our claims. Let's write our HO, then H1. H1. Okay. Let me move this down so we have enough room. HO and H1. Okay, I'm gonna make this to be 18. Good. Now, I see a researcher claims that the average wind speed in a certain city is 8 miles per hour. A sample of 32 days has an average speed of 8.2 miles per hour. The standard deviation of the population is 0.6 miles per hour. At alpha 0.05, is there enough evidence to reject the claim? Use p-value method. So this researcher claims that the average speed is, so keywords here. Look at the keywords here. Here is the keyword. Average speed is. See? Is the keyword right there. So is means equal. And that equal, you can use equal in null hypothesis. So you have HO mean equals 8 miles per hour. Per hour. That is your claim. That's a claim right there. Now, H1 is the opposite of that. Speed. The average speed is not equal to 8 miles per hour. Okay, per hour. So, an alpha we are given, the alpha is 0.05 again. It can be, they'll just give us 0.05. It can be it can be 0.05, it can be 0.01, doesn't really matter. Of course, it matters depending on the situation. Now we can write our summary statistics, because this is equal and not equal. That means it can be left side or right side. So that this is a two-tailed test. Whenever I have equal or not equal, it become a two-tailed test. So when you're doing p-value method and if it's a two-tailed test, once you get a p-value, multiply it by 2. That make it I will give you the final p-value. So now let's put our test some of the statistics here. Because the average speed is 8. So mean equals 8. And it collected a sample of 32 days, n equals 32. And then find the wind speed to be 8.2 miles per hour. X bar equal, let me put it, like I normally put it, X bar is small draw. X bar, okay, equals 8.2 miles. Now, for the standard deviation, we use delta equals say 0.6 miles, 0.6 miles. The population standard deviation. Now let us run the test. Let me write this down. Mu, population mean is 8, sample size of 32, sample mean of 8.2, population standard deviation of 0.6. So that Z will now give us so these are what we're gonna put in the formula. Okay, for Z. Z becomes equals, I'm gonna all this. Okay. All right. Okay. Equals Z is equals 8.2 minus mean of 8 divided by standard deviation of 0.6 over the square root of sample size of 32. Now let me write this down, and we can now go and put it on the calculator. 8.2 minus 8, but 0.6 divided by the square root of 32. So let's go and do it in the calculator. So we got 8.2 minus 8 divided by standard deviation of 0.6 over square root of 32. 1.89, or actually it's 1.88888569. So 1.89. So I got 1.89. So this is the I'll put it right here, put it on the formula, and then we can copy it to our main workbook. 1.89. Okay. 1.89. So you have go and put right there. 1.89. So I put right here. 1.89. So now, like I said, this is a two-tailed test. So you have two sides. Let me show you. Of course, when I say two-tailed test, you already know how it's gonna look like. That'll be like this, and we have our line here. Then we have our bell curve. Okay. We have the center line. Then, like I say, you gotta be two sides since it's two-tailed test. It's gonna be two sides, and then this side as well. Then you can now share both sides. So those shaded place, if I answer for there, then it means it's less than the P-value. The unshaded place is the acceptance region. See? Okay. Now, let's see. Let's find out p-value now. P-value. The p-value here, we p-value we look for 1.89 in the table of normal distribution, 1.8 under 9. So 1.8. See 1.8 right here. But you gotta go under 9. Okay. See, oh, this is under 8, this is under 9 right here. It's right here. See 9. And you follow it, you see 1.8, now 1.8 for a Z. 1.8 go under 9. 0.4706. 0.4706. Now, since it's at the tail, you gotta subtract it from 0.5. So we're gonna do 0.5 minus 0.4706. Now, because it is going to be 2 tails, so you gotta do it the way you're gonna do it. You gotta do 2 times that. So if it's 1 tail like the other one we did, you can just subtract and get an answer. But because it is 2 tails, then 2 times this answer that we're gonna get here. So let me write this down. P-value 2 times 0.5. Okay, 0.000 minus 0.4706. Okay, so 4706. So it's gonna be 2 times that because it's 2 sides, 2 tails. So let me go and put it on the calculator. So I have it here as 2 times 0.5, okay, minus 0.4706. Okay. Okay. 2 times that. 0.0588. Okay. So we got 0.0588. That's that. Which is 0.0588. Excuse me. So you have it right here. 0.0588. Now we're ready to make our decision. Now our alpha is this. I'm gonna make this sense. Okay. Our alpha is 0.05. Okay. Now the p-value, our p-value value that we calculated equals 0.0588. And because this p-value is bigger than alpha, we would not reject HO. So so since it's bigger than, if it's smaller, we reject. Do not reject HO, which is null hypothesis HO, because the p-value of 0.0588 is greater than the alpha of 0.05. So we don't reject. Now, that means we do not reject null hypothesis. Unfortunately for us, the claim is in the null hypothesis. So our conclusion now becomes conclusion. Okay. Becomes that there is enough evidence to support the claim that the average wind speed in a certain city is 8 miles per hour. So we did not reject HO, and HO has a claim this time. So we can say that there is enough evidence to not reject. So there is not enough, there is enough evidence to support the claim. The claim that the average wind speed in a certain city is 8 miles per hour. Okay. Any question on this one? So again, we started by stating our hypothesis, identifying the claim, getting our alpha, getting the summary statistics, calculate the z-value, that means run the test, get our p-value, we compare the p-value to the alpha. If it's smaller, we reject. If not smaller, we don't reject. Like this platform we did. Okay, we rejected because and this time the claim is in the alternative hypothesis. So we say that there is enough evidence to support the claim. Yeah, the claim is in the no, there's also enough evidence. So just a coincidence. Any question on this? Good. No question. Good. Now, that is for now. We have done hypothesis testing for large sample. Let's look at when the sample size is small. When the sample size is small and we don't know the value of the population standard deviation, what we do is we use the sample standard deviation, and then we use what we call the t-test, not z-test. So we use t-test when the population is normally or approximately normally distributed, but the population standard deviation is unknown and the sample size is small. That means when you say that sample size is small, I mean that n is less than 30. In which case we're going to be using t-test, which is instead of using z here, we use t. Where t represent the like the one represent the calculated t. The other one represent the calculated z. This one t represent the calculated t. And for the standard deviation, we use what we call the S, which is the sample standard deviation. You can see right here. And every item the same. Now, remember from when we are doing confidence interval, at the t distribution, we'll be using this table of t called the student t distribution, which is based on the degrees of freedom. You can see right here. We used it last week. Sorry, last 2 weeks when we were doing confidence interval. You can see the degree of freedom here for 2 TEL and for 1 TEL. So we got student t distribution when the sample size is small. As we know from last week, I think last 2 weeks, as a matter of fact, the degree of freedom is equals to n minus 1. So that is how we calculate the degree of freedom. N minus 1, where n is the sample size. Let's look at this example here. It says here that a job placement director claimed that the average starting salary for nurses is $2,000, and in the year 2000 is $24,000. A sample of 10 nurses salaries has a mean of 23,450, and the standard deviation of 400. So it said, is there enough evidence to reject the director's claim at alpha 0.03, 0.05? They're all using 0.05, 0.05. For some reason, they just like 0.05. Anyway, so let us do it. Again, first thing is to state the hypothesis and identify the claim HO and H1. Okay? Now, this director is claiming that the average starting salary for nurses is in year 2000 is 24,000. Is. So now to test that claim, so that means claim is right here. Is means equal sign. So you're going to have to be in the null hypothesis. Okay. So now have excuse me mean equals $24,000 for the claim. Another one's mean is not equal to. Okay, not equal to 24,000. So this is the we're going to be using critical value here because this is the t-test. I mean you can use p-value for t-test too, but for this one we're using critical value. So our alpha is 0.05. Okay, I'm going to right here. Alpha equals 0.05. So the first thing to do now is to find our get our critical value. We said a sample of 10 nurses salaries has. So to test this claim, they selected a sample of 10 nurses salaries, and that salary have a mean of 23,450, and the standard deviation of 400. Is there enough evidence to reject director's claim at alpha 0.05? So this is a two-tailed test. So we have our n. To find the critical value, we need to find our n and the degree of freedom. Okay. N equals 10 nurses selected. So degree of freedom, DF, equals n minus 1, which means 10 minus 1, which gives us 9. Okay. Now we can now get a critical value. Instead of Z alpha over 2, we're going to use T alpha over 2. Alpha over 2 equals, now we get alpha is 0.05. We go under 9 degrees of freedom. We have 9 degrees of freedom. This one is relatively easy to get. So 9 degrees of freedom and alpha 0.05. So you go to the table of student T distribution. See the alpha for two tails. You can see that you have double prime. So that alpha 0.05 is right here. So it's right here. Now you're gonna follow it under 9 degrees of freedom. So you follow it under 9 degrees of freedom. Right here. That's why you get 9 degrees of freedom. So it's plus or minus 2.262. So okay, let me put this greater specific here. T alpha over 2 is 2.262. It's gonna be plus or minus 2.262. Okay. So I have it right there for you in the paper. Let me put it in the paper. So you gotta make it plus or minus 2.26 because it can be in either side. It can be lower on the lower side on the upper side. What is my plus or minus? Okay, plus or minus 2.262. Okay, good. Now with this, we can now get our summary statistics. Our summary statistics will say that we say that the mean is 24,000. Okay, I'm just gonna put mean. Okay, equals 24,000. Okay. Now, for a sample of n equals this example of 10 nurses, which is 10. Okay. Let them know the sample mean x bar. X bar. So I feel like I'm gonna put the bar on top of it. X bar. Okay. And they say that this is out of that 10 nurses, they have a 23,450. 23,450. 23,450. For the standard deviation, we use sample standard deviation, okay? X, which is X, equals, sample size is small and is unknown. 400, okay? With that, we can now run the test. In this case, let me write this down. I can run this. So remember this T is a critical, T alpha is a critical value. With critical value. Critical value, which is a T alpha over 2. Okay. Now to run the test, let me write this down. X bar is 23,450. Mean is 24,000. Sample standard deviation is 400. Okay, N is 10. Okay, let's go and put this in the calculator to get our test statistics. Let's run the test right there. Sorry, and not in the other workbook. Sorry, my mistake. So in this camera, we're going to be using T here. Okay, if you click on this. Okay, click all this. So T S bar minus mean, but we're not going to use we're going to use sample standard deviation, which is S. By the square root of N. The same formula, just a slight modification. You can even see it. I think they have it here. They have it here already. Okay, I didn't put it here. Okay, I didn't put it. So now we can plug these numbers in. So you have X bar is 23450. 24,000 divided by standard deviation, the standard deviation of over R. Okay. 400 is standard deviation. Square root of 10. So I have, let me put it in. Z equals 23,450 and 24,000 divided by 400 and square root of 10. Okay. Let's go and put this in the formula. Okay. So we have 23,450 minus 24,000 divided by standard deviation of 400 over square root of 10. Negative 4.3481313783. So rounded, it's going to be negative 4.35. Okay. Let's go and put it in. 4.35. I have, okay, give me 1 minute, let me check something here. Yep. 4.35. So I'm gonna go over there and put negative 4.35. Negative 4.35. Okay. So now we have this is the test statistic. So I'm putting in the main workbook. Right here. Now we can make our decision. Okay. I'm gonna move it down so we can have an option. The calculated critical value. Since our answer is negative, we consider only the which is T alpha over 2. T alpha over 2. equals, move this and make this adjustment. TF over 2 equals, remember it is critical is plus or minus 2.262. So now, since our answer is negative, I'm going to consider negative 2.262. So negative 2.262. But I'll be using the absolute value. Okay. So of course, the absolute value of this. You know how we do it? We draw 2 lines on it. The absolute value of this number. Okay. Maybe equals 2.262. Now this is come on, place this. Okay. Now let's try the second one, which is remember this is a decision. Our answer is T negative 4.35. The calculated T equals negative 4.35. Again, we're using the absolute value. Okay. Okay, which means that they give us 4.35. So that means you can see that 4.35 is bigger than 2.262. So because of that, we reject the null hypothesis. If the answer is bigger than the null hypothesis, than the critical value, we reject. So the sense reject the null hypothesis because 4.35. Now, remember this is negative, so I'm going to put it, but it's actually 4.35. I mean, negative 4.35. But we used it to compare them. That's when I was comparing them. Like if I put negative here and negative here, algebraically, negative 2.262 is bigger than negative 4.35. But that's why we use the absolute value to compare them. We already know that in this curve, this bell curve for two tails, negative number means that it's on the left side. That's all. Put it on the right side. So that's why we use just the absolute value. Now we have this here as because negative 4.35. Let's see, 4.35 is greater than the critical value of 2.262. Yeah, reject. So conclusion. Now we rejected this one, the claim. So we rejected it. So that means the claim is on null hypothesis, and we rejected it. That means the claim is not correct, which means that there is not enough evidence to support the claim that the average starting style hypothesis in 2000 is 24,000. So conclusion. It says there is insufficient evidence to support the claim that the average starting salary of nurses in the year 2000 is 24,000. There isn't enough evidence. Any question to this? Any question?
No question.
No question. Okay, good, excellent. Now, sometimes you might be asked this as in a different way. Like they might give you the numbers. They will not give you the mean, and they will not give you the standard deviation. That means you have to calculate it by yourself. Like this type, they didn't give you the mean. They didn't give you the standard deviation. And they say, is there, let me start by reading the whole question. It says here that an educator claimed that the average salary of substitute teachers in the school district in Allegheny County is less than $60 per day. A random sample of 8 school districts is selected, and the daily salaries in dollars are shown here. Let's see. Is there enough evidence to support the director's claim at alpha 1.10? So here, unlike the other ones that we did, like this one that we just did, they give us the mean for the population, they give us the mean for the sample, and they give us the standard deviation. But here they didn't. They didn't give us none of that. Okay. So that means we have to calculate it by ourselves to be able to answer the question. So what we do is to use the remember the formula I gave you at the beginning of the semester, how to find the mean and the standard deviations. You use that. Now that will take you a long time to get. I mean, you can get the mean easy by adding them and divided by the number of items. Where we're gonna have problem is the standard deviation. So to make that simple, you can get them using a calculator, scientific calculator, and find it. Or you can use Excel. I recommend Excel because when you start working, most of the time you'll be using Excel or a spreadsheet, some kind of spreadsheet. So now the first thing is to find state the hypothesis as a matter of fact. Say an educator claimed that the average salary of substitute teachers in a school district in Allegheny County is less than. So the keywords are as for the average salary is less than. Okay, and the keywords is less than can only be used in the alternative hypothesis. So you have our HO and H1. I'm going to make them 18. HO and H1. Okay, like I said, it says it's less than $60 per day. Less than it can be used only here. So we're gonna put mean is less than $60 per day. And that is the claim. The no, I will say the opposite. That means that mean is greater than $60 per day. So that means, but we cannot use greater than in that place. You can only use greater than or equal to. So, excuse me, I gotta put mean first. Mean is greater than or equal to $60. Okay, so let us find our alpha is, say at alpha, test the claim at alpha. Okay, that'll give us alpha 0.10. Since 18 in size, font size. Now, how many nurses just select? It said a random sample of 8 nurses. Sorry, how many school districts? A random sample of 8 school districts is selected. Okay, I have 8 school districts. N is 8. So that degree of freedom, which is DF, equals N minus 1. Eight minus 1 is 7. Now let's get our critical value T alpha over 2. Actually, this one is T alpha because say less than is pointing on the left side. So you gotta be a negative critical value. T alpha plus alpha. You gotta be some people will say negative T alpha. So I'm gonna put T alpha equals. You go and look for it under alpha point, the critical value under we call it critical value. Critical create value alpha, T alpha, excuse me, can find it on the table of student T distribution under 7 degrees of freedom and alpha 0.10. You go there. Okay. Alpha 0.10. This is one. This is to 2/3. This is for 1/3. 10 right here. So under 7 degrees of freedom. See? 7 degrees of freedom. And then alpha 0.1. So it's 1.415. 1.415. Put that there. 1.415. 1.415. Now, because this is pointing on the left side of the claim, so you can make it negative 1.415. Now we're ready to run the test. We need to find the mean. So I'm gonna put the mean. Okay. And put those symbols right here. Then I collected a sample of make this mean be to 18. So excuse me. A sample of 8 school districts. Okay. N equals excuse me 8. Then for sample mean X bar, we have to calculate it by ourselves. Okay. Sample mean S bar. It's right here. Have to calculate this ourselves. Then sample standard deviation S. We have to calculate it by ourselves. So first, to get these two, the mean, the total of the mean is $60 per day, right? For the population, is $60 per day. The one we need to calculate is the sample mean and the sample standard deviation. So, like I said, you can use the formula method calculator, or you can just go and use Excel. So I put it in, I put this in Excel so we can have the sample mean and sample standard deviation. So let me go and get it from Excel. So we have where we put it. I put it right there. I think it's somewhere here. Okay, good. So that will simplify the work for us. So I'm gonna highlight that side. This will make it 14 or even 16, so you can see it clearly. 18. Okay. So I'm gonna have sample mean, okay. The one is sample standard deviation. Okay. Okay. So mean, of course, mean is equals. Make sure I'm seeing this. Okay, equals average. If you pop out here, double click on this, highlight it, press the enter key, give me the mean. Standard deviation is equal STPEV, pops out. We're looking for the sample, that means that S. Double click, highlight it, press the enter key. So let me write this down. I got okay, sample mean S bar is 58.9. Sample standard deviation is 5.08. Okay. Now, we have all this. We can now go and put them in and then run the test. Okay. Sample mean we get it as 8.9. Sample standard deviation we got it as 5.08. See? So we are almost done with it. Now we can now go and run the test with this. Write them down. Population mean is 60 and it's 8. Okay. So we're gonna run this. Excuse me. I have go to the other workbook where I have the formula. So we have T equals this. Okay, T equals, make all this. Okay. Sample mean is 58.9. 58.9. Population mean is 60. Divided by 5.08, which is standard deviation. What is square root of 8. 8. So let me write this out so we can now get it from the calculator. T equals 58.9 plus 60. Well, 5.08 square root of 8. Let's go and put this in the calculator. We have this 58.9 minus 60 divided by 5.08. Yeah, over 8 over the square root of 8. Okay. Then it is 0.6124. So it gotta be, it is 0.61. Yeah. It is 0.61. Okay, we have, you can put right there. It is 0. Okay, we're gonna copy this and paste it in our main workbook. This one here. Now, it's time for us to make our decision. Now, remember, the critical value is negative 1.415. Let me copy that from here. So let's make our decision here. Okay. Decision. Oh, I have it down here. Okay. Decision criteria. I have this critical value, and which of course, like if your answer is negative, that's what you're gonna be doing. Like the previous one, we're gonna make it absolute value. Okay. All right. Okay. Which is, oh, excuse me. Okay, let me put right there. Equals 1.415. Now the calculator the answer from the calculation is negative 0.61. That means the calculated T calculated T equals negative 0.61. Which, like I say, if it's in this form, you make it which is looking for absolute value. Okay. The absolute value for this, you're gonna have it right here. Let me put it right here. Equals 62.61. Yeah. Now, you can see that the answer is less than the critical value without just HO. Do not reject null hypothesis as HO, since the calculated value of 0.61, okay, is less than course, you know that the calculated value is negative 0.61. So you're using absolute value. Yeah. Less than the critical value. Value of 1.415. Yeah. So the decision is not to do not reject. Conclusion. So we do not reject the null hypothesis. So a null hypothesis says that because you say that an education clip that the average salary of substitute teacher in the school district of Annagali County is less than $60 per day. So we do not reject this. I mean, this claim is not good. So that means there is not enough, there is insufficient evidence to support the educator's claim. Okay. And put that way. There is not enough evidence. There is insufficient evidence. Insufficient evidence to support the educator's claim that the claim that the average starting salary of substitute teachers in the school district of Allegheny County is less than $50 per day. Yeah. That this. Okay. So conclusion. Okay. Any question on this, guys? Yeah. Now, since there's no question, we'll round up. Now remember that those are small few who have attendance of 70% or more, who I told to send me an email. Some of them have already received their makeup work. If you attend that, up to 70 or more, you still have from now till December the 10th to push it up. So that will qualify you to make up. Now, if you haven't sent you already, you can send it today so I can, by tomorrow or next, I can give you their class makeup work. Okay. Remember, it's 5, but your attendance have to be up to 70% or more. Now, let me take your names down. I got Brooks, I got who else? Jasmine, Shode, Jasmine is here. Marcus Graham, I got her name, Rick Washington. I got Brooks. I got Brooks. Yes, Miss Brooks.
Yes, I have a question. I had emailed you today about it, about the makeup work. So that's good to know. But for some of the items, it's locked. So are you going to unlock the items that we asked for?
Which are you referring to? Have you sent me the email today already?
Yes, I did.
So what item are you talking about?
So I have 2 homeworks that are locked.
Yeah, when I respond to you, I will unlock it. I will unlock it for you.
Okay.
Yeah.
Okay. Thank you.
You're welcome. So probably by tomorrow night, you must hear from me.
Okay.
You just follow the direction from there. Yes.
And then I had another quick question for the makeup ones that only had 1 attempt. Are you going to unlock those? Because I had just sent you 2 via the email. I attached it to the email. So should I wait for you?
No, for the classwork, I'm gonna give you something different because yes. So just wait for my email. You get everything it will answer all your questions. Okay.
Okay.
I got Peacock.
I'm here.
Yes. Morgan. Okay, I have Peacock. Floyd. I got Floyd here. So if I call your name, you can leave. Unless you have a question for me. Chair. I think I have a chair already. Yeah, I think I have a chair. Yep. Parish. Thank you. I have it. Rodney Jones. I have Rodney here. Okay. Sharia Q. Okay. Sharia, is it? Did I call it the right way? Sharia? Is that how you say it? Sharia? Hello. Yeah. I think I got everybody. So I see you guys next week. Okay. I'm not sure. Okay, next week is Thanksgiving Day, right? Hello. Can you hear me,
Yeah,
guys?
next week's Thanksgiving.
I think it's 28th, right? Yeah, I mean, if you're able to, so I know, is anybody anywhere? 27th. Um, yeah, 27th. We'll see. We'll see. Okay. But don't forget to continue working on a project. Okay. Hmm. I'll let you know if you're gonna have a class on
So
26th.
this week we have 2 assignments due, and then on the first we have the project due.
Yeah, project is due on the 1st of December. Yeah. So the other assignment is only homework that was that homework that was due since last week that is due this week and the test. Other than that, nothing else. Project is due next day on the first week of December.
So for the assignments, you said we could email you 5 of them.
Yeah, five. Each of them have have name. Like if classwork 1, homework 1, or they have names. Choose the name of 5 that you want to redo.
And it could be either classwork or homework.
Yeah.
Okay. All right. Thank you.
You're welcome. All right, guys. Enjoy your weekend, I say. Your weekend started earlier than mine, so have fun and be careful out there, okay? And I'll let you know next if I have a class next week, okay?
Okay, bye.
Yeah, have a nice night, yeah.